Hi students, welcome to Nilagiri online video classes. In last class, we had discussed about the our fourth unit, that is waves and oscillations. In that unit, we have there are several topics: simple harmonic motion, simple harmonic oscillator. Next, compound pendulum, torsion pendulum. These are topics are in fourth unit. We have already discussed what is simple harmonic motion, what are the necessary conditions for simple harmonic motion, what is the mathematical form of if any body making simple harmonic motion, that motion expressed in a mathematical form in a second order differential equation, that is a simple harmonic motion equation. What are the general solution of the that second order differential motion equation, already we seen last section. Today we discuss about the compound pendulum. This compound pendulum already we are all are very well known because of we are done compound pendulum experiment in our lab in our college. So we see the compound pendulum here. So what are the use of compound pendulum? Which physical quantity find that by using compound pendulum experiment? That is one theoretical question here. So we finally get g value, small g value. Small g is a acceleration of earth. That standard value is, what is that small g standard value? 9.8 meter per second square in centimeter. So elate 980 centimeter per second square. This is the standard value of g, small g value. This is the acceleration of earth. Sometimes some books are given 10 meter per second also. No worry about that value, but we strictly say that what is the g value in meter per second, 9.8. We take our near to decimal values, that is 10. What is compound pendulum? What kind of motion or what kind of oscillations made by the compound pendulum? This is also simple harmonic motions. What is the required condition? What is necessary condition for if any motion treated as a simple harmonic motion? Just to simply say that if any body having simple harmonic motion, that acceleration direct is proportional to the displacement of that body. That is a one condition for if any motion treated as a simple harmonic motion. So see here, compound pendulum also making simple harmonic motions. How to prove that simple harmonic motions made by the compound pendulum? See here, any rigid body which is mounted that it can swing in vertical plane about the horizontal axis passing through it is called physical or compound pendulum. Compound pendulum having another name also, physical pendulum or compound pendulum, whatever may be, no problem. So see the diagram here. See the length of the compound pendulum is L, first end is S, and the second length of the pendulum, center of the pendulum C, and ending of the pendulum O. This is the compound pendulum length. So when I apply force on the pendulum, just bring some side with apply a small amount of force, that pendulum make vertically swings about its equilibrium position. So it have a knife edge. Let m is the mass of the pendulum and L is the distance of the C from S. The body makes an angle theta with vertical. The moment of its weight mg about the axis of oscillation through the S mg L sin theta. This is the restoring torque. In case of simple pendulum, we are called restoring force. In case of compound pendulum, we are calling restoring torque. Why? Because it is twisted like that. It may be slightly twisted and slightly making turns. So when we call rotation properties, that there appear torque definition. So what is the torque? If you want any body rotating by applying force, that force is nothing but called as a torque. Okay, so that is the here torque, restoring torque tau is equal to minus mgl sin theta. If theta is very small, making with the vertical axis, so we write the tau is equal to minus mgl theta. So what is the relation between moment of inertia and torque? Already was that tau is equal to I alpha. What is alpha? Alpha is a angular acceleration. So what is the angular acceleration and change of angular velocity? What is velocity? D omega by dt is alpha. What is omega? Omega is equal to d theta by dt. Omega is equal to theta by dt. So we substitute here. Finally write the alpha is equal to d omega by dt. So d by dt of what is d omega? What is omega? D theta by dt. So d into dt is d square theta, d theta square. So finally alpha get what we get alpha d square theta by dt square, d square theta by dt square. This is the alpha value. Okay, so we substitute here alpha tau is equal to I alpha. Alpha place now we substitute d square theta by dt square by using equation 1 and equation 2. This is equation 1 and this is equation 2. No problem. Consider balancing these two equations. I is equal to d square theta by dt square is equal to minus mgl theta. So put I is equal outside. I mgl by I into theta. Simplify that, minus omega square theta. So add that omega square mgl by I. So d theta by dt square. What is the d theta by dt? Alpha. So what is alpha? Angular acceleration. What is alpha? Angular acceleration. Alpha is directly proportional to theta. So what is the condition? This it is the simple harmonic condition. So the compound pendulum also making simple harmonic motion. So angular acceleration proportional to the angular displacement. The motion is called simple harmonic motion. What is the time period? What is the definition of time period? The time taken for one complete oscillation. The time taken for one complete oscillation. Here also we consider the pendulum make one oscillation. How much of time is required to complete that oscillation? That is called time period. Generally, time period formula is tau t is equal to capital T is equal to 2 pi by omega. So here we know that omega square value here. Here is omega square value. Square go outside. It becomes root. So omega is equal to root mgl by I. Omega is equal to root mgl by I. So we substitute the omega value here. So 2 pi into under root I by mgl. This is the time period. By the simplification. So interchanging of the center of mass, what happens? This kind of result we get. Finally, what we find out that by using compound pendulum, By using compound pendulum, we measure the small g value. What is that small g? Acceleration of earth due to where we conduct the experiment. What is the g value there? That g value find out by using compound pendulum. So time period of compound pendulum is equal to 2 pi under root L by g. So if I find the L value by using this graph, so keep the L values on x-axis, uh, keep in time period values in y-axis, draw the graphs like this, and draw a horizontal line with axis. The coincident of this lines points are P, Q, R, S. The distance between Q, R, S is L1. The distance between P and R is L2. To find the mean value, L1 plus L2 by 2, that gives the capital L. Substitute this equation. T is equal to 2 pi under root L by G. So I want G value, squaring both sides. Squaring both sides, T square is equal to 4 pi square L by G. So I want G is equal to 4 pi square L by T square. This is the G formula, 4 pi square L by T square. By keep on all variable values in this equation, we get G value. We get the G value, meter per second square or centimeter per second square, by using compound pendulum. Okay. In next class we are discuss about the combination of simple harmonic motions. Okay.